Alright, so for this video we're going to talk about isotopes. Isotopes are atoms of the same element with a different number of neutrons. So we talked before about how the number of protons in an element determines the atomic, or the identity of that element. So for example, carbon has 6 protons, always. That's what makes it carbon, and you can verify that by looking at your periodic table and seeing that its atomic number is 6. So carbon has 6 protons, and we can see that with all 3 of these different atoms having 6 protons. Now the difference is carbon can have 6 neutrons, 7 neutrons, or 8 neutrons. Those are the 3 reasonably common isotopes, or the stable isotopes of carbon. Now you can see that the vast majority of carbon exists in this form here. 98.9% actually exist in the carbon-12 form. 1.1% exist in the carbon-13 form, and only less than 0.1% exists as the carbon-14 atom. So this number here is the mass of that atom, which you get by adding the protons and neutrons. So the thing about isotopes is it's still the same element. So you got the basic same chemical properties, same reactivity. This one's still carbon. The only difference is the mass. Okay, the neutrons only affect the mass. So real quick here, we're going to talk about 2 different forms of isotope notation. This is just how you write or you symbolize an isotope. So the first one is called shorthand notation. So with shorthand notation, what you want to do is first write the atomic symbol. So let's use oxygen here. Alright, we are using oxygen. So the first thing you want to do is write the atomic symbol, which is just, O. Next, you want to write the mass number. So we're going to use oxygen, we're going to use the oxygen atom with a mass of, we're going to go oxygen 16, the most common one. So shorthand, you're going to write the atomic symbol first, and then you're going to write the mass number. The mass of this one just being 16 AMU. Okay? Now the second type is longhand notation. Okay? With longhand notation, instead of writing the symbol, you write the name. So you would write oxygen, okay? Then you put a hyphen, and then you write the mass number, which is 16 of this particular isotope. So two different notations here. I personally prefer the longhand, but you need to be able to read and recognize both of them. Okay, we're going to do some quick practice with isotope notation. I'm going to give you an example of an atom, and I want you to write the notation for that isotope. Alright, first we've got an atom with 16 protons, 18 neutrons, and 16 electrons. Go ahead and pause the video now and see if you can correctly write both the shorthand and longhand notation for this isotope. Unpause it when you're ready for the solution. Okay, so we're going to do shorthand first. Now with 16 protons, all we have to do is check our periodic table and we see that this is sulfur. Alright? Now, the other thing you need to write is the mass number. You get that by adding the protons and the neutrons. Okay? Protons plus neutrons equal mass. Okay, so 16 plus 18 is all we got to do here. The mass of this sulfur isotope is 34. So that's our shorthand notation. For longhand, what you're going to do is write out the name. We have sulfur. And you write the mass, which is 34. Again, I prefer this because it's really easy just to say sulfur 34. We have a sulfur atom with a mass of 34 AMU. Alright, let's try another one. So we've got 12 protons, 13 neutrons, and 12 electrons. So go ahead and try to write both notations, and then come back and check if you're right. Okay, so 12 protons means that we have the element magnesium. Alright, now to get the mass, again we add protons and neutrons, so this would be a mass of 25. And for longhand, we just write magnesium 25. So that's all you got to do. So next we're going to talk about something called atomic mass. So you have different isotopes of each element. Each isotope has a mass that's going to be a whole number because you're adding protons and neutrons, which each count as 1. So you're always going to have a whole number. Atomic mass is the weighted average of all isotopes of an element. So you're really just averaging the masses of all the isotopes of that element. The key word here is weighted. Okay? You're weighting it by how common that isotope is. So if you remember the carbon isotopes that we had on that first slide, let's pull those up again. Okay, they have a mass of 12, 13, and 14, but if you notice, this one over here on the left, carbon 12, is way, way, way more common. Okay, so the average is going to be skewed a lot towards this one. The average is going to be a lot closer to 12 since the majority of our atoms exist in the carbon 12 form. So the formula to calculate atomic mass is actually pretty easy. All you're going to have to do is just mass times abundance for each atom. Okay, so you're going to take the mass of the atom, which in this case would be 12, 6 plus 6, 12. That mass times the relative abundance. Okay, so you take the mass times abundance for each atom. Okay, so you're going to calculate it for this one, and this one, and then you're going to find the sum of that. And that will be your weighted average. So let's try an example. So we have an element here with 3 isotopes, just an imaginary element. The mass of the first isotope is 16 AMU and its abundance is 95%. So here's our information for the first element. Alright, the mass of the second isotope is 17 AMU, atomic mass units, and the abundance is 4%. And the mass of the third and final isotope is 18 AMU, and its abundance is only 1%. Alright, so right now looking at this, before we do any math, we know that our average should be somewhere in between 16 and 18, since we're averaging numbers that are all between there. So our average mass is going to be somewhere in between there. The abundance is skewed a lot towards the first isotope here. So I would think the average would be a lot closer to 16 since the vast majority of isotopes exist in that form. So what I want you to do is calculate the atomic mass. If you know how to do it, go ahead and do it. If not, you can use this as an example, and then we'll do one more after this. Alright, so what you're going to do, again, is mass times abundance for each isotope. So for the first one, we're going to do 16 times the abundance, which is 95%. Now the thing that you want to be careful about is anytime you do math with a percentage, you have to convert it to a decimal by dividing by 100. So instead of 95%, we're going to use 0.95. Alright, so this is the first one, plus same information for the second one. 17 is the mass. Okay, and our abundance is 4%, so that's going to be 0.04. And same info for the third one. So 18 is a mass, and our abundance is 1% for that one, so 0.01. So if we do the math here and we solve, we're going to get 16.06 AMU. If you're in my class, I want 3 significant figures, so we're just going to do 16.1 AMU. Okay, so that's how you do it. Let's try one more problem. Alright, so in this problem, we have an element with 2 isotopes. The first one has a mass of 84 AMU and an abundance of 72.2%. The other isotope has a mass of 87, and we do not know the abundance. And we want to know what is the atomic mass. Alright, so our first isotope, let's pick out our key information. There's our mass, there's our abundance. Okay, second isotope, we've got the mass, but we were not given the abundance, so a little bit of a curveball here. So all you really need to do here is recognize that the abundance, since all isotopes of this element, all atoms of this element exist in one of these two isotopes, the total percentage has to be 100%. So if we know that the first isotope is 72.2%, the other isotope has to be an abundance of 27.8%. And now we solve. So the atomic mass is going to be 84 times 0.722 plus 87 times 0.278. Okay, now you do the math here and you will get 84.834. And I want three significant figures, again, if you're in my class. So we're going to do 84.8 AMU. Which makes sense. It's between 84 and 87, and it's, tilted toward the 84 since the abundance is so much higher. So that was just a really basic overview of isotopes for you guys. Includes the notations that you're going to need to know how to recognize and use, and it includes the main calculations that you'll need to do, whether it be adding protons and neutrons or calculating atomic mass. So please like the video and watch my other ones. Thanks.